Here is the text formatted into paragraphs without skipping any words. Imagine a telescope powerful enough to see back to the birth of galaxies, to the very edges of our universe. That's what scientists have in the James Webb Space Telescope, an instrument so advanced it lets us glimpse into the earliest eras of cosmic history. Recently, astronomers were scanning one of Webb's deep field images, observing countless points of light scattered across a canvas of endless blackness. Each speck a galaxy, perhaps, or something more mysterious. Amid the many splodges, as scientists often call them, a particular one caught their eye, glowing brightly against the dark backdrop of space. This object was something else, something strange. It was not just another galaxy among many. This one had been visible even in some of the earliest data the telescope captured. And yet, despite its great distance, it was remarkably, almost inexplicably bright. Typically, objects at such extreme distances are faint due to their vast distance and the expansion of the universe. But here it was, shining intensely, defying expectations and theories. How could this be possible? The astronomers couldn't simply overlook it. They realized that to understand this bright object, they needed better data, more clarity. So, they used spectroscopy to peel back its secrets, to analyze the object's light in greater detail. Spectroscopy allowed them to measure its distance and composition with unmatched precision. And that's when they confirmed the nearly unbelievable. It was indeed one of the farthest galaxies ever detected, if not the farthest. This was more than just a distant light. It was a beacon from the very edges of the observable universe, a window into an era barely imaginable. This galaxy, they realized, wasn't supposed to exist. It stood out not only because of its brilliance, but because it challenged everything astronomers thought they knew about the universe's beginnings. And this was just one mystery among countless others that Webb was uncovering. In recent months, the telescope has taken images that reveal strange objects spread across the vast emptiness of deep space. These aren't galaxies as we know them. They're different, baffling even the most experienced astronomers. In a single deep field image, they found thousands of these peculiar objects. Some of them don't resemble any known type of galaxy or cluster. They seem to be entities all their own, and scientists have no idea what they are. It's not just a question of categorizing these objects. Their existence itself throws into question the foundation of our current cosmological theories. Each new observation, each new speck of data from the Webb telescope, paints a picture of the early universe that simply doesn't align with what scientists had previously assumed. The familiar models can't explain these findings. It's as if we're seeing an entirely new version of the cosmos, one we've never been able to imagine. The reason this is so shocking is that for decades, scientists have relied on a timeline that puts the universe's age at about 13.8 billion years. According to this model, galaxies slowly formed in the billions of years that followed the Big Bang. But these strange early universe structures Webb has observed defy that timeline. They're too massive, too bright, too developed. Some of the world's top physicists, including Nobel laureates, have suggested that we may need to rethink everything. The discovery has led some to the radical idea that maybe the universe didn't have a beginning in the way we thought. It's almost as if the so-called early universe isn't early at all, but something else, something entirely different from what we've imagined. We may need to rewrite the beginning of time itself. If this sounds extreme, that's because it is. The standard cosmological model, known as the lambda cold dark matter lambda CDM model, has been the foundation of our understanding of the cosmos. According to this model, dark matter and dark energy dominate the universe, shaping its structure and evolution. But the objects Webb has detected don't fit this model. These entities seem far too massive to have formed so early in the universe's history. According to lambda CDM, the material available back then couldn't have come together quickly enough to form objects of such enormous scale. If these objects are indeed galaxies, they would need to have consumed all the ordinary matter around them, forming in a way that simply shouldn't be possible under our current understanding. It's as if they've skipped billions of years of cosmic evolution and appeared fully formed. But what if these aren't galaxies at all? That's the question haunting scientists now. What if these are something else entirely, something that exists outside our frame of reference, outside our established categories? The discovery challenges not just our knowledge of how galaxies form, but the very fabric of cosmic history. The Webb telescope has not just found a few anomalies, it's revealed an entire realm of objects that defy explanation, casting doubt on the foundation of modern cosmology. We may be looking at phenomena that can't be explained by any existing theory, a reality that would send ripples through the scientific community for years to come. For nearly a century, since Edwin Hubble's revolutionary discovery in 1929, we've known that the universe is expanding. Every galaxy, every star, is drifting further away from us as space itself stretches outward. But this expansion isn't happening in a straightforward way. It has no central point, no clear origin. From any point you stand in the cosmos, everything appears to be moving away from you, as if you're at the center. This is one of the great mysteries of cosmology. The universe doesn't have a center in the traditional sense. It's expanding equally in all directions, an effect that becomes even more puzzling as you dig deeper. What's even stranger is that this expansion is accelerating. Distant galaxies are moving away from us at faster rates than nearby ones, an observation that implies something extraordinary. Imagine looking into the depths of space with the Webb telescope. As you peer farther and farther, you'll notice galaxies moving away so quickly they appear to vanish into the blackness of the cosmos. This boundary, where galaxies recede from us at the speed of light, is known as the Hubble sphere. Beyond this boundary, they should be lost to us forever, unreachable because they're moving faster than light can travel back to us. However, something unexpected happens here. Due to the accelerating expansion of space, more and more galaxies beyond this boundary are becoming visible. The Hubble sphere itself is expanding, allowing us to see galaxies that should be impossible to observe. This cosmic trick of light and distance is one of the universe's greatest paradoxes, and it extends our vision to an unimaginable limit. But even with this vast horizon, there's still a boundary, the observable universe, which stretches about 92 billion light-years across. Beyond this boundary, the universe continues, filled with galaxies and stars we'll never see. What we do see, however, when we look to the edge of the observable universe, is a wall of faint light known as the cosmic microwave background. This light is the afterglow of the Big Bang, a relic of the universe's infancy. It represents a time when atoms first formed and light began to travel freely through space, a moment captured in every direction we look. This background light tells us of a time when the universe was hot, dense, and filled with energy, slowly expanding and cooling over billions of years to become what we see today. Yet, when Webb peers into these far reaches, it finds something mind-boggling. The oldest galaxy ever detected by the Webb telescope, known as JADE's GSC 13, appears to have existed when the universe was only about 290 million years old. This galaxy, now beyond the observable universe's limits, is essentially frozen in time. In our view, we see it as it was in the ancient past, a glimpse of a reality that has long since changed. Today, it may have merged with other galaxies, evolved beyond recognition, or ceased to exist altogether. Its light, which once shone brightly in our direction, has now drifted too far away to ever reach us again. Think of the enormity of this idea. The universe stretches beyond anything we can observe, filled with galaxies, stars, and other phenomena that will remain forever out of sight. And this limit, the edge of the observable universe, is unique to our position on Earth. Other intelligent beings scattered throughout the cosmos would have a different observable universe, seeing stars and galaxies we'll never know exist. According to the standard model of cosmology, roughly 14 billion years ago, all of this, the observable universe and everything beyond, was compressed into an infinitely small, dense point, a singularity. But if the universe is infinite, as it seems to be, then it may have always been infinite, even at its beginning. The Big Bang, then, wouldn't have happened in one particular spot. It would have occurred everywhere at once. The first galaxies, rather than forming in one region, emerged across the entire universe. The formation of matter wasn't isolated to a single area but spread evenly across the cosmos. This understanding, however, is being called into question. The Webb telescope's recent discoveries are forcing scientists to reconsider these theories. They expected to find the first stars and galaxies at the edge of our observable universe, a faint glow at the cosmic frontier. Instead, they discovered mysterious bright objects that don't seem to fit any known category. These objects are far more massive and fully formed than any early galaxy should be. Researchers have made numerous observations, but they can't seem to make sense of what they're seeing. Even a study recently published in the Astrophysical Journal has done little to clarify these strange findings. Scientists discovered 87 possible galaxies that could have existed a mere 200 to 400 million years after the Big Bang. According to current models, this shouldn't be possible. Dr. Jing Yan, an astronomer and one of the authors of the study, explained that even if only a few of these galaxies are confirmed, it would mean a complete overhaul of our understanding of galaxy formation. The discovery suggests that galaxies might have formed far earlier and far faster than current theories predict. But how? How could matter coalesce into such dense, massive structures in such a short period? One particularly baffling object is a galaxy so unique it challenges every rule of galaxy formation. Typically, galaxies contain a mix of gas, dust, and other materials, and only a fraction of this material transforms into stars. Yet, the Webb telescope has identified at least 3 galaxies that have somehow converted nearly 100% of their available material into stars. Such a phenomenon is unprecedented in our standard model of cosmology. It's believed to be impossible for a galaxy to turn all of its atoms into stars. This anomaly raises questions not just about how galaxies form, but about the very nature of the universe itself. Now, some astronomers suppose that these objects might not be galaxies at all. They could be something else, something that doesn't fit into our current understanding of cosmic structures. If they are galaxies, though, then the Big Bang model, a pillar of modern science, might be fundamentally flawed. How could the Big Bang have created galaxies like these in such a short time? How could it have led to objects that defy the very principles of cosmic evolution? The truth is, no one really knows. These objects represent a mystery on a cosmic scale, a challenge to the very foundation of science. The discoveries made by the James Webb Space Telescope are pushing the boundaries of our understanding in ways that are difficult to comprehend. The telescope's unprecedented resolution and sensitivity have revealed new cosmic phenomena that could fundamentally alter our views of the universe's evolution. As Webb peers deeper into space, it is opening a window not just into the distant past, but into a cosmic puzzle that may change everything we thought we knew about astrophysics. One of the most astonishing aspects of these findings is the nature of the objects Webb has observed. These galaxies, or whatever they may be, are far more complex and developed than expected for their time. The universe, according to our current understanding, should have been a much less structured place only a few 100 million years after the Big Bang. Early galaxies were thought to be small, faint, and relatively simple. Yet, the objects discovered by Webb seem to challenge this view. These structures are mature, luminous, and in some cases incredibly massive, much more so than anything should have been able to form within such a short time span. Many astronomers are now wondering whether the models used to predict the formation of galaxies and other cosmic structures are fundamentally flawed. The Lambda CDM model, while remarkably successful in explaining many aspects of the universe, may no longer be sufficient to account for the new data from Webb. If these strange galaxies did form that early, it suggests that galaxy formation could have occurred in a much more rapid and violent process than previously thought. Instead of slow mergers and gradual accumulation of matter, it might have involved more complex and dynamic events that were previously unimaginable. What's more, these galaxies seem to be more than just early versions of the galaxies we see today. They display unusual features, with some showing intense star formation, while others appear to contain unusually high levels of heavy elements, things that would have taken billions of years to accumulate in the standard model. This raises questions about the process by which matter and energy coalesce in the early universe. Was there some unknown mechanism at work that allowed these galaxies to form so quickly and efficiently? Could the laws of physics themselves be different in the early universe, or have we misunderstood them entirely? These anomalies are not limited to the distant past. They also raise important questions about our current universe. If the conditions that allowed these galaxies to form so quickly existed in the distant past, might similar processes be at work today? hidden from our view by the vast distances separating us from them? Could there be entire regions of the universe, far beyond our reach, where the same kind of rapid cosmic evolution is taking place? Could our own Milky Way, or other galaxies we observe, be part of a much larger and more complex web of cosmic processes than we have ever imagined? The implications of these findings extend far beyond our understanding of galaxy formation. They may lead to a reevaluation of everything we thought we knew about the structure and dynamics of the universe. If the early universe was far more active and populated than previously thought, what does that mean for our understanding of the Big Bang and the evolution of spacetime itself? Could we be looking at evidence that challenges not just the formation of galaxies, but the very origins of the universe? Another potential implication is that these objects may represent something entirely new, cosmic entities that do not fit within the current framework of cosmology. Some scientists have speculated that they could be the result of unknown or exotic physical processes, possibly linked to dark matter or dark energy, which remain mysterious forces in the universe. Could these objects be manifestations of dark matter or dark energy clumping together in ways we don't yet understand? Or perhaps they are a glimpse into a deeper, unseen layer of reality that remains hidden from our conventional senses? As these discoveries continue to unfold, the scientific community faces a crucial crossroads. The models and theories that have guided our understanding of the cosmos for decades may need to be radically adjusted or even abandoned. The role of dark matter, the nature of galaxy formation, and the timeline of cosmic history all appear to be in question. And as these revelations emerge, it's clear that the universe is far more mysterious than we ever could have imagined. We are at the precipice of a new era in cosmology, one where our understanding of the universe's past, present, and future may be dramatically reshaped. Webb's discoveries are not just unveiling the history of the cosmos, they are rewriting it. The potential for new theories, new understandings, and even entirely new frameworks for interpreting the universe has never been greater. What is certain, however, is that the universe is far more complex, far more wondrous, and far more mysterious than we could have ever imagined. Only time will tell where these revelations will lead, but one thing is clear: the search for answers has only just begun.